Good morning. Welcome to the next of our different LSEC webinars, Cybersecurity Experts from Home. Good to have you here again with us today, and good to see that all of you are actively participating and following what it is that we do. Today's webinar will be yet another one in the space of cybersecurity in itself. As you know, every second week we organize a webinar, and then next we on cybersecurity, and the next is again something on 5G, at least for the next week or so. So this week we have a very interesting topic for everybody working today in cybersecurity, which is artificial intelligence. It is something that is definitely going to impact us all. If it's not already today, then definitely in the future. Artificial intelligence is very much hyped, of course, but it's also very active and very interesting, especially from the spirit and from the perspective of people working in cybersecurity, because there we have seen that it has been a very useful tool today already in its current asset and environment, and is expected to continue to be so in the near future. Welcome from my side. I'm Ulrich Selzaks. I'm the Managing Director of LSEC, which is an association of IT security companies that has been around for 2 decades. And we've done these webinars since now quite a number of weeks under the aspect that we won't be able to meet in person, and so that we try to find a way to support our communities in an online way, and so therefore, of course, the webinars. So the webinars are specifically oriented to be taking place on every Tuesday morning, Tuesday noon, and then on Thursdays. We're going to add something on the Wednesdays, which is related more to our industrial session. So I hope that you will be able to see those as well. Those will be notified under the TRIF brand, as you can see here. Now, back to the topic of today. I think as early as somewhere in the 80s, we already understood from a human perspective that cybersecurity and artificial intelligence were connected together. This is the one of the very important scenes in the movie War Game. And War Games specifically was focusing on this idea that the computer might be able to take over by itself, but also with the idea that a computer in this case is fed by something which is something that we might not fully understand how it operates, namely an artificial intelligence. And then at the same time, what we found out through the movie was that people that invented it and that scripted the movie were so smart to actually have the computer playing against humans. And so this is where, of course, cybersecurity takes its place, because there was a hacker kid that tried to hack into the Pentagon machines, and this way he launched something which was not really supposed to happen. So fast forward, I think about 40 years later, maybe, we are seeing today's effect of that concept that might have already started earlier on in the science fiction novels. But already today, I think we know that some of these things actually might happen. And so the way that we see today is a number of companies that are applying cybersecurity. We see companies like Darktrace that have launched the idea already a couple of years ago. Companies like IBM, CrowdStrike, that have built their platforms on the top and on the basis of machine learning and behavioral analytics components and technologies. IBM called it cognitive security at some point in time, and I think we can see it, how it's evolving in a very fast pace. Where it's definitely useful is in the way that we see today how people need to react to incidents. We know that the number of cybersecurity threats and incidents are just increasing on a day-to-day basis. And so where yesterday we had maybe a number of people that were capable of looking into the logs and into the different systems before the time of endpoint protection, when we still had some tools that were capable of watching over maybe all of the different security components that we had. And the time that our security information and event management systems seems, in other words, we're still spitting out data that were maybe comprehensible for people also to understand. Today, the situation is slightly different. We have to watch over many different environments. The perimeters have gone. We need to make sure that we can understand not only what we have on the assets internally, but also the different activities that are being done on the outside, and preferentially also how the outsiders are working. So trying to understand on the basis of the intelligence that we can gather what's actually happening from that side. So in the typical security model, where we look into prevent, detect, and now in this consideration also predict and respond, artificial intelligence definitely will play a role. And already today, things like machine learning and the concepts of using analytics and advanced analytics to understand where some of the activities are happening that we are monitoring are really important for us to be able to watch over and to manage the challenges. It's really a challenge in identifying associations, and the complexity of all of these different assets is what is also worrying us from the security industry. And we try to get some understanding on how all of these relations works, and that's really what some of our challenges are going forward and into the future. So how to work with these things is a bit of a challenge, and that's what we try to do also within LSEC. So together with quite a number of companies, LSEC is a digital security catalyst. We work with enterprise end users. We work with different vendors and research institutes. And actually today we are working on some cases whereby we are investigating the next steps of artificial intelligence, how they can be used for cybersecurity. But more about that at a later stage. Maybe a couple of other considerations. As you might see also from behind me, we are working on cybersecurity for robotics, where of course AI is a major component. So it's not really about only how can we use AI for cybersecurity. The question is also how can we secure AI, and especially knowing that a lot has to be done in securing the robots. There's also a lot that needs to be done in how to try to secure the AI within the robots. But I would say, without further ado, I'm going to hand over the words to our guest speaker of today, which is a very renowned gentleman, Ralf Benzmueller from G DATA Cyberdefense, calling in from likely his home office, as we are expecting them to do so, cybersecurity experts from home. Good morning, Ralf. How are you today? We're going to unmute you in this case first. Yeah.
Good morning. Yeah, welcome everyone. I'm happy to be here in that early hour. It's quite a challenge. Yeah, so this is. Did you swap the screens already?
Yeah. So I finished
sharing
my part of the screen.
Where I usually stay, where I'm working. This is G DATA campus on the left upper side, and the entrance hall on the upper right side.
You need to restart sharing your screen, Ralf.
Sorry?
We can't see it yet. You need to start resharing your screen because we can't see it yet.
Okay.
That's because I took over and basically hijacked your screen.
Yeah.
Yeah, now it's coming up.
Okay.
Yeah.
Then again, so this is where I usually work. This is G DATA campus on the upper left side, and the entrance on the upper right, the bistro in the middle. And the piece from the lab on the lower left side. Yeah, I'm from G DATA. We're a German company. Come on. We're a German company. We do IT security solutions, and we do that since the very beginning. We were founded in 1985, which is 35 years ago, and published the first antivirus product in 1987, which is 33 years ago. And we now have more than 500 employees and a much wider range of security solutions and services which are run in two branches. The one is consumer, the consumer branch with antivirus, internet security, total protection, also for Mac OS and Android. And the second branch is the business, with all the solutions that are necessary to protect against cybercrime. These services are available worldwide, but of course the majority of our customers is in Germany and the German-speaking countries and in Europe. In 2015, 5 years ago, we founded the G DATA Advanced Analytics, which is concentrating on the stuff that Ulrich just mentions, the more the incident response area, the malware. It came from the malware analysis, and some incident response teams contacted us and asked whether we could support them with malware analysis during an incident. And later on, we also got access to incident response cases ourselves. And it became that much that we said, okay, we need to set up a separate company that is running on a G DATA flag, but is doing product independent services like incident response, security consulting. This comes after the incident. People ask you, what can I do? And then it's about pen testing, auditing, malware analysis, and also awareness trainings and managed services. This is where we are heading to at the moment. My role in G DATA is I founded the G DATA Security Labs and have been leading it since 2004 until 3 years ago. And now I'm responsible for technology, cooperation, and research projects. Okay, before we start, some terminology. I'm not sure how much I have to how much basics I have to give, but I just want to make sure that we're talking about the same thing. So artificial intelligence, in my opinion, is much more than just machine learning. Machine learning is a part of artificial intelligence. That is actually that part that is where data come in. So if you derive knowledge from data, that's machine learning. Then, and if you're using neural networks for that purpose, then it's deep learning. So that's basically what I think is. And it all interacts with data science because they use a lot of the same technologies, but in data science, the approach is not concentrated on the algorithm, but more focused on the data side and what can I do with the data, and then okay. So how do machines learn? So typically, if you have a research question, then you build your research hypothesis and you find suitable data. It's not different with machine learning as well. You need to find, you have a problem, you want a solution, and you have to make clear what you want to achieve before you start looking for your data. Once you're clear with that, the data need to be collected, and once collected, prepared, and features need to be extracted so you can start the training process, which means the classifier. You then select the best machine learning algorithm for your purpose. Probably develop your own classifiers and start the training with the training data. And this is not all the data, but it's a subset of all your data because you need a part of it for testing whether the classification is correct. So you need test data. Yeah, that's the next step. Apply the model that has been trained to the remaining test data, and if it's not good enough, start the training loop again and do that as long as as is needed to come up with useful useful results. And then once and at that point you have a model, and with that model you can go to the outside and apply that model in your real world scenario to your real world problem. So in the best case it works. If it doesn't, you can start all over. Okay, that's the usual thing that happens with how data is linked. Yeah, AI has a success story. Ulrich pointed out some points. I will point out some others. So Deep Blue defeats Garry Kasparov in chess in 1996. IBM Watson wins Jeopardy. That was in 2011, and that's when the IBM Watson business came into the market, or that pushed IBM Watson solution very much into the market. 2016, AlphaGo wins against the Go master Lee Sedol, which is again a really big step, because Go is supposed to be the most complex game in the world, and the machine beat one of the best players in the world. And then a year after that, a machine beat another machine in Go's after just 4 hours of reinforcement learning. So Stockfish was one of the strongest Go playing machines, and AlphaGo beat it after 4 hours of training. So with that background, people thought, or might come up with the idea that AI can do everything. If they can beat us in chess, then they can learn from data without further ado, and so they're omnipotent, and everything is easy with just if all you need is data, and then everything else can be done by the machine. Unfortunately, this is not the case, but let's first have a look at the different fields of application. There are plenty. Speech recognition, natural language processing, image processing, industrial sensors, robotics, we've seen that, games, financial transactions, are not advertising and recommendation system. Google would not be the company that without machine learning that it is at the moment, and many more. And the idea, of course, if AI can work in so many fields and has so much success and is so omnipotent, then it can of course help us defend against cyber threats. There are several areas which I mostly just mentioned. I will go deeper into malware detection in a minute, but so the first thing that happened, that's already, I don't know, that goes back to the 90s when spam came up. The spam detection also came up, and a technique called base filter, which is now supposed to be one of the AI framework technologies, came up and just calculated a number of words in emails. So if you found special peaks or special words and special in emails, then like Viagra or whatever, then these emails were tagged as spam. But the spammers circumvented that quite quickly by just appending a few paragraphs from the latest news, or from Moby Dick, or from Wikipedia, which then just confused the base filters, and the word distribution was cancelled, or was broken. Yeah, we will go into malware detection in a minute. Another big thing or a big field of application in cyber defense is anomaly detection. This is this is a different field so this has nothing to do with the typical classification, clustering or prediction. It's just outlier detection. And so that already starts with what is an outlier, or what is normal, or what is an anomaly. So so we are back to this loop. If you're not clear about this question, all your efforts in that area will probably not succeed. Yeah, the other thing is this is also based on data, and who says that your normal data is not polluted? If you have already malware in your company, it may just become part of the normal behavior set. And yeah, okay. So there are a lot of issues with anomaly detection. Anomaly itself doesn't mean it's malicious. It's just different. And this is another thing that is coming up. Usually, anomaly detection is used in network traffic. So a lot of log files are scanned with these methods, and if some outliers are detected, it will be reported to the security operations center or the security operation team. And if you talk to people who work in security operation teams, they are fed up with false alarms by these systems because the accuracy of these detections is the big issue that people are working on, but that is an issue, and it will remain an issue for quite some time. We've seen threat intelligence, and also EDR, forensics. Another thing is anti-phishing and fraud prevention. We are using image recognition for the detection of phishing sites, and we also do URL reputation checking with neural networks. So that's another field where artificial intelligence mechanisms can do a good job. Early warning systems, secure software development. Yeah, and in 2016, there was the DARPA Cyber Grand Challenge where autonomous cybersecurity systems were tested and were fighting against each other. That was another cool event, which came up with a new discipline. So they found their own vulnerabilities and fixed it. So they defended their own systems. Okay, let's go to the malware detection. The first thing is malicious files. So if you look at malicious files, they have a lot of static features, they have surface properties, and of course they have a lot of content. Content can be problematic because most of the malware is packed, and all you see is then the packed content unless you unpack it. So and that's a big problem because there are so many different packers. Usually it's not only one packer, but probably it's up to, one of the, it's not uncommon that there are 8 layers of packing in malware. So they use 8 different packers until they come up with the final malicious code. So this is a problem to get to the content. So on the surface itself, it's difficult to really identify what the malware is doing. But if you have access to the content and it's an executable, then of course you can look at the imports, you can look at the PE headers, you can do byte engrams, you can do histograms on the entropy. And also you can disassemble the code and work with the disassembled code. On Android, it's the manifest that you're usually after, or the decompiled classes.dex. And if you look at PDF files, it's the abstract syntax tree of the JavaScript included, the layers of the PDF, the encoding and the compression algorithms, and many more features that you could use for that. The idea here is that it's static. You just look at what is there. You don't run it. It's just, yeah, it's surface. This sometimes works, but mostly it doesn't. So in our lab, we had the first scanner for that in 2008, where we analyzed the PE headers and a lot of other stuff, and never came up with a reasonable result or a reliable result for scanning stuff. It worked quite well for some families, but it was error prone in many other cases. So that's what we had, our experience from the lab. If you look at the more dynamic part, if you look at the behavior, then of course you can still look at the static features, but the behavior in the file system, in the registry, what's going on in the operating system, what's going on in the memory and the processor, which API calls are there, which drives are accessed, what hardware access are there, system performance. If the machine is running on high volume, then you probably run a miner, or if there are a lot of file system access, probably a ransomware is just active, but that may be one possibility, but it may also be another. The other part or other set of information is, of course, network activity. You can look at local networks, at the internet, at the generated network traffic, and also just the amount of transferred data, because often metadata is all you have if you look at encrypted communication. And most of the botnet traffic is currently encrypted, so all you have is metadata. But interestingly, in that area, network, the size of the packets, the number of packets that are sent, and just these metadata give you often enough information to tell botnet traffic apart from normal traffic. So that's there are some reliable networks, neural networks and other machine learning methods that can reliably predict botnet traffic. But the thing is, the one thing that I want to point out, there is this AI-based malware detection, and there is the traditional AV. So there's this opposition, which is actually not really an opposition, because so what's called traditional AV is not present in the market. It's probably CLAM AV, which is that thing that is traditional AV. But every AV product at the moment has machine learning and cloud technology included, which is and has has the features to dynamically analyze behavior, and yeah. So okay. But the point here is that both the sensors of the AI-based solutions that report the data back into their backends and the AV, they use the same features, and they run in the same system context. So they're just playing the same game, and the point is that the rules that have been derived from the data in the back end, the models that just work on the front end, are a synthetically generated set of rules, whereas AV signatures are another set of rules, but it's man-made and it's machine supported and also run from the backend. So yeah. Okay. Yeah. How to circumvent? I mean, another thing is AI-based malware detection is also attackable. Anderson on the Black Hat conference in 2017 came up with 3 major ways to attack machine learning model. The first is, if an adversary has your model, then he can, of course, manipulate trees, decisions, gradients, weights, and he can create extra trees for exceptions and stuff like that. So and that has been done by several people, Anderson himself, and Papano for Android malware, and yeah. So if you have access to the model, then you can of course manipulate that. The other thing is you don't only need that. You can also have access to a score. So if you can get the scoring, the internal scoring of the machine, then you can of course probe the output and manipulate the input in a way that the score gets worse and or better in the sense of the attacker, in terms of it's not detected anymore, and it's sufficient to just have access to, is it a good sample or is it a malicious sample? So all you need is the scanner itself, and if you run it against a collection of antivirus samples, of malware samples, then you can train so-called generative adversarial network. You know them from pictures. So if you look at the scaling here, this picture is manipulated in a way that the machine thinks that this is clearly a rifle. And it might be a rocking chair or a revolver, but it's not a turtle. So, but this is done by overlaying and manipulating the image, and you can do the same with malicious samples. And this is what MaIGAN, Malicious Generative Adversarial Network, is doing. MaIGAN is a framework which generates malware samples which are not detected by machine learning based detections. And what they are doing is quite easy. They add some code to the executable. They change some headers. It's really easy changes, and still they get a higher than 99% success rate, which means they bypass machine learning based detection with almost 100% accuracy. So that's plenty of potential for attackers. So the one thing here is, so the machine learning is also quite good tool for attackers. That's the one thing. And the other is, if you control the data, you control the detection. This is why I'll come back to that in a minute. But first, I want to go into detail about that packer, about these runtime packers. So we were tired of simply rewriting the same signature again and again for the same code, and So so the idea of that thing, if you want to deal with runtime packers, so if the code comes to the processor, it has to be unpacked. So which means in memory, the code is no longer packed. It's just packed on the file layer. And that's why we were thinking about in-memory scanning. But in-memory scanning is extremely expensive in terms of performance. So it costs a lot of performance, power, and so on. And it usually renders even the best system too slow. So that is usually a no-go that has not been able to use by now. I'm sorry for this slide. I couldn't find the English equivalent, but I'll walk you through it. So if you look at the cybercrime background here, they develop the core malware. So during that time, they don't earn money. So this is an investment of the cyber criminals. And when they are finished with the development, they want, of course, to monetize it more than once, and that's the return on investment phase, and that's where the packers come in. So they take the same code again and again, and they just repack it, because then on the surface, the traditional AV signature-based detection cannot detect it anymore. And so once the signature is out, they repack it. It looks different, and then we as an antivirus company have to create new signatures. So that's a never-ending story. And yeah, we wanted to break through this this circle. And came up with the idea of deep ray as an enabling technology. Again, so we look at the surface, there are a lot of features. I won't go into details about that. They're quite easy to access, and they're mostly surface features for like file size, image base, function names, size of code, and so on. And if you look at these two features, file size and size of code, and you see if the file is big, or if you have a high file size and the low size of code, then so in the upper left corner, most of the stuff is packed. But it's not as easy as that. That's why we needed to come up with a multi-layer perceptron with several hundred layers to split up the room. So, and if that white thing here has to be evaluated, it clearly fits into the not packed area. Yeah, and so what this multi-layer perceptron can do is it can tell it can tell quite accurately whether a file is packed or not. And what we do is we use that as a filter. And once that filter says this is a packed file, we start the in-memory scanning process and do also use a taint to inherit a marker to processes that have been created from one process. So code injection within other processes can also be detected like that, and so we can see what's going on in memory, and the good thing here is it's not only helping against so that helps perfectly against the packed malware. It ends that cycle, but it also detects fileless malware as it's used in a lot of APTs and a lot of stuff, and rules that we derive for the in-memory scanning are quite similar to traditional signatures, and they last for months. So with the same rule, we can detect the same stuff again and again. So within a few weeks, we identified 60 different different variants of emotet, which is one of the most dangerous malwares at the moment. Yeah, so that's a good. That's in my opinion a really good use case for machine learning, because it's enabling a technology that would not have been that we would have not have been able to use without that technology. Okay, some final remarks. Good data is the mother of successful AI or machine learning. All you need is data. That's and domain knowledge is often neglected. That's unfortunately the case, but it's not true. The data scientists acknowledge that, and they usually work with people from the domain. So if they work with medical data, they usually have doctors with them. Yeah, but if you just collect data and you don't know what it's good for, then the data is not correctly labeled for your purpose, then it's garbage in, garbage out. You don't get anything from what you want. And what you have to make sure is that your data have the structure that they need for solving your problem is already in the data. Otherwise, you won't get things. There's a lot of effort going on in the deep learning area at the moment, where they try to skip over this step, or where they deal with this step of data handling, where they generate samples, where they try to make stuff more robust. So where they manipulate training data, or not manipulate, probably extend the training data by artificially generated content. So there's a lot of work going on in this area, and deep learning may probably help a little with that, but the better the data, the better your results. That's just it. Yeah, and usually, usually if you're dealing with machine learning, you have to keep in mind that it's about probabilities and statistics, and probability means 99%. But if you make 1% error in a framework where you have to cope with 100,000 samples, yeah, then it's you get 1,000 samples wrong, and that's probably an amount you don't want to deal with. That can help. So if you have to read 100,000 log files, and then the remaining, and the system can filter out 99,000 of it, and you only have to read 1,000, then it's really helpful. But yeah, so it's about probabilities, and usually the results are a trade-off between detection accuracy, or so-called recall, and the number of false positives. Okay, another thing is that brings me to the last point: data change. So the big assumption about database learning is that the training data that you use are quite similar to the real-world data that you're running with. So, but usually data change over time. That's called concept drift. So especially in the area of malware, the data from 3 weeks ago are not the same as today, and they're probably not really suitable. So the change in data is tremendous in the area of malware, and this is where you can raise a big question mark whether machine learning and AI is really good for malware detection, or whether it's a good place. And Thomas Dulin did that in a keynote at CyberSecurity conference. So if you look at the scenario, our adversarials, they constantly change their ways how they attack systems. And if you look at the stuff from the other side, if you look from an attacker's point of view, then a lot of things really are stable. If you want to look for vulnerabilities, the environment for running executable code are not changing tremendously. They are quite similar over years, and so fuzzers are really good for machine learning, because the environment stays the same. Also, if you want to exploit stuff, the layout of the memories is not changing that much, and so supporting exploitation is probably a good field for machine learning. Phishing and deception is quite interesting, because this is also a very heterogeneous field. But if you look at what Google has been doing, they have been serving ads, and they have been optimizing their click-through rates for decades now, and they have been using machine learning in a massive way. And phishing is not much different from their advertising problem. So they also have the problem of increasing the click-through rates, and they might also use machine learning approaches to optimize their revenue. Lateral movements of APTs. So there are some standard things that are quite constant, and if you have an arsenal of stuff you can do, then you can automate that and use machine learning to bypass security mechanisms. And the same is the case for password cracking. So if you look at password cracking in terms of I mean, not brute force, but if people use words and word lists and stuff like that, then machine learning and natural language processing can help a lot in password cracking. Okay, summary, key takeaways. Machine learning and artificial intelligence has a high potential. There's a lot of things it can do, and it can have a big impact both in all the industry that's already applied, and of course the cybersecurity industry. The majority of artificial intelligence and machine learning is painful data work. The data scientists acknowledge that. AI algorithm developers are a little bit reluctant, but yeah, it's hard data work. There's still a lot to learn for machine learning, and it's probably better suited for attackers than it's for defenders. And sometimes, so that's the last key takeaway. Sometimes it's not the big high-tech solution that you need to solve a problem. Sometimes it's just a little bit of inspiration and creativity. Yeah, thank you for your attention. I'm open for questions.
Okay, thank you very much, Ralf. That was great. Definitely in the perspective of giving us an oversight, giving us an indication of what it actually means and what it could mean, how it's what the status is of today and how it works, and especially also putting the right context in all of this, because I think, as you rightfully put, it has huge potential. But we need to make sure that we can adapt ourselves to make the right preparation for it in order to structure the data properly, and of course also to be ready in organizing ourselves internally for the capturing of data and the organization of the total platform behind it. So there have been a couple of questions from the participants. Not too many though, but I think the biggest question, I guess, was how easy is it to circumvent, in this case, the AI or even the machine learning and behavioral analytics, the way that you presented them. Have you been doing some tests on this? What's basically the results for the time being?
Well, I don't quite get the question. I mean, are you asking how it's working, or how that? Come on, how?
I think the dog doesn't want to go away. Yeah, the question, simply put, is how easy is it to basically?
So it's about the process of creating the samples. So
no, it's more about how can you actually deflect what the AI engines should be investigating. So because
okay.
you can develop, of course, also algorithms that the detection engines can capture. But actually having them fading away from the real problems, if you like.
I mean, that's a different topic that I can cover another time, because it's a topic, the topic of how secure is AI. There are plenty of, or there are a number of ways how you can undermine AI technologies. And this is just one. But the good thing is there are always, I mean, you can create these generic generative adversarial samples, so you can use them for both attacking purposes, but you can also use them to train your own model. So if you create your model with the same kind of manipulations, and they have been described in the paper, and they're really easy, and you can, and of course you can think of much more manipulations. And if you do that in a systematic way, then you won't be cheated by an attacker with that thing. But you have to do it. I mean, so the point is, these machine learning things are not invulnerable, and they're just because they're machine learning, they're not attackable. It's, you know, they run in the same environment as we do, and they have the same. They face the same problems and the same attack surface, and that's, yeah. But yeah, you can be prepared. The effort for that thing, for that training is I don't know. You need a bunch of samples, which is easy. You can get malware samples easily. And once you have them, you just train it, and you start manipulating it. That's so.
The more worrisome.
It's not rocket science.
That's understood, and especially I think knowing that there's many tools out there already today that you can use, cloud-based data engines that can easily be used to try to utilize some of the mechanics behind it. The other concerning thing is that you put there AI and machine learning is probably more suitable for hackers. You raise it a little bit, but how would you see that happening? I mean, how do you see today that hackers are actually using the key technologies to serve it to themselves?
Well, I mean, it's okay. Let me just go back to the, oh, come on, this is the slide. If you look at the fuzzers, there's a thing called AFL, American Fuzzer Lob, which is the de facto, which is one of the standard fuzzers, and it has been the base of most of these cyber grand challenge of DARPA systems that have used it for vulnerability scanning. And this thing, of course, is using machine learning already, but this again is a dual use tool. I mean, pen testers and auditors also use fuzzers. And once you know, and some of that stuff is already integrated into development platforms. You can run a fuzzer against your newly developed software, and when the fuzzer finds something, then you can fix it. So this can be both a tool to help create secure software, but it's also a tool for attackers. If you didn't use these tools and you didn't apply to secure software development principles, then they will find your bugs and they will exploit it. The tools are out. So there's a tool for analyzing the heap layout which makes it quite easy to plant your piece of malicious code in the right spot in the heap. So that's yeah, these tools are out there, and whether they have been in use for an exploit that's been running, we don't know. But the tools are out there, and I'm quite sure that they're not only used by people who work on the pen testing and white hat hacker side.
Yeah. Okay. Yeah. So I think the question was also definitely in relation to how strongly can you see something like this happening today? As you say, the tools are out. It's maybe difficult to detect that there's a real engine behind it, because of course that's the purpose of these things, is to make sure that you don't see that there is some machine behind. In other terms, coming back to how can one prepare himself to be organized in order to use more effectively AI engines. How do you organize it within G Data today? Do you have custom built engines and codes that run on data, and you are continuously trying to strip data out to put it in the right formats on a manual basis, or do you have some tooling also to do that that you have been developing over the last couple of years?
Oh yeah, that's a long story. I mean, we usually, or we are using a lot of machine learning in the backend. Of course, our analysis systems create log files and threat intelligence and indicators of compromise in abundance. So we usually, I mean, we have several ways to represent it, but the most effective way we are working with it is graphs. Because you can find relations between samples, and also, so you can find just an easy example.
So visualizing what you think is happening, more or less.
Sorry?
Visualizing what you think is happening.
Yeah.
Okay.
So So yeah, so it's graphs. Yeah, it's easy to visualize. That's another thing, and you can really easily find out what belongs together, what's a family, and what behaves in a similar way, what looks in a similar way, so that you can create signatures, and you can make the decision on the graph and on the graph-based analysis result. Whether you create a behavior rule or whether you create a signature for that file. I mean, a signature for that file or a checksum for that file is usually the first thing that we do, because we don't want that thing to spread. But just for the long-term solution, we have several options to roll out new rules or just to roll out new signatures, and this is all supported by these data and machine learning, and there are plenty of machine learning algorithms that give us several indications. We've done some. I mean, if some of these tools or some of the combinations of these tools are saying this is malicious, we automatically generate a blacklist entry. So then it just takes a few seconds until that thing is blocked. Okay. But even if you have to analyze it, then we have a lot of more options. So I mean, we're used to that signature approach, and we understand quite good what it's doing, how it's working. Yeah, how it's working, and when there are errors, or and we don't understand that with machine learning, because you never know if you train a model what the features are that they trigger on, and if you have false positives, you don't know how to react, but retrain the model, and then you get probably other false positives. So this is a technology that we don't, that we are not familiar with, and that we just use in the backend, where we have the experts, and they're just supporting the experts, and but the experts make these decisions. So that's our way to use machine learning. Okay. Other companies make that decision on the endpoint. With the given, I mean, they also have false positives. And another thing is they need a really long time to train the model. I mean, if you adapt your general model to the data that you see in the company, that usually takes several months until you can use your new system in a test mode, and then it's still running under surveillance, and until it's really working reliably, it takes probably half a year until. Okay. Yeah. So that's not an easy install. It's not like installing that in an afternoon. Or so, yeah,
it's definitely interesting, because in order for the machines to work, it requires a lot of human effort and labor to get them to that point. So I think that's one of the key messages here. Well, thank you very much, Ralf, for sharing your expertise and your findings with us today. This was definitely a great experience. So maybe a couple well, thanks. A couple of other thoughts for this, because Ralf has been so generous in sharing some of their works. We've seen some other ways that machine learning and AI is being used today in cybersecurity, in terms of next to the adversary hunting, also in active monitoring, and directly in incident response. We see more and more also the use of bots, for instance, when it comes to incident response. So I think there's many different applications today that we can start seeing. But as Ralf already put it, and as we already also have seen what's out there today, we're definitely not there. We can see definitely there's quite a number of interesting pop-ups of AI technologies and machine learning, but it requires still a lot of work in order to get there. One of the earlier points that we raised, garbage in, garbage out, I think has been also acknowledged here. We see also an interesting application, and that's maybe something of consideration as well, is the use of AI technologies. I think Ralf partially also pointed to it in the development and in explicitly coding on how to use machine learning to find where maybe some errors could be put in, where some of the coders are putting in some specific hard-coded components into your codes that should not be allowed. So I think that's definitely something to consider. Is going to DevSecOps via AI Ops, that's called. So and that's of course not only applicable to cybersecurity but also to many other places and domains. And I think, as we've been indicating already over the last couple of weeks in these webinars, is the most and increasingly urgent needs in order to understand what is actually being done in these programs and in the developments, is to get to something like a software bill of materials for us as cybersecurity experts to be able to quickly grasp what the challenges are of a specific system and to understand where we need to go for. And this specifically when you buy, of course, different technologies, and we use the example of a car here, which is basically being constructed out of many different components and tools. And we'll continue probably on that topic today during lunchtime when we have our next webinar series. Today it's Microsoft. Mm-hmm. We know Microsoft, of course, from the IT world. But more strongly, Microsoft is moving into the industrial world with Microsoft IoT, with the recent purchase of CyberX on cybersecurity for industrial systems. So we've asked today Bart from Microsoft to talk a little bit about Azure IoT and then Sentinels for industry. So that's going to be happening at noon today. So hopefully you'll be able to join us there. And then later on this week, we'll be working towards identity and access management again, together with ForgeRock, some in-depth use cases. And then we'll also have the GDPR Salon online with a panel on what has happened with GDPR 2 years after its basically establishment. Yes, it seems already like yesterday, but it was 2018, May 25th, when the GDPR was actually activated. And then next week, we'll continue our Cybersecurity from Home Expert series with 5G again. And then the week afterwards with Inti from Integrity. And we'll be seeing Ralf again also next week in the Network and Information Security discussions at noon. So looking forward to that as well. Tomorrow, we'll have one of the first digital manufacturing transformation webinars, which is happening also in the morning. So if you're into industrial transformation for manufacturing, then please join in that one as well. So with this, I would say thank you very much for attending, and thank you very much, Ralf, for sharing your morning coffee together with us, and definitely also sharing your thoughts and ideas. And I'm hoping to see you back again soon live, hopefully in Bochum at your offices still in September. And otherwise maybe a little bit later on in the year. Thanks again.
Yeah, thank you. Bye.
Bye.